are back again looking at our procedural dungeon generation. So, last time we tidied up this code a bit and we added the concept of symmetry, which gave us some interesting patterns. So we were able to now specify that a generation algorithm should generate horizontal, vertical, or like both horizontal and vertical symmetry, which creates some pretty interesting looking designs. So we were able to get that working and got some fairly interesting results out of that with both drunkard walk and with cellular automata. The drunkard walk one tends to generate nice sort of cavernous areas with symmetry, whereas the cellular automata, I mean, this is like some sort of weird abstract art, right? But some of the bits that aren't quite there yet, though, are... So this has got a lot of regions that are inaccessible. So once we've sort of created this map, if we then wanted to play it, like if we spawned the player or something in this small region here, there'd be no good. We wouldn't be able to get in or out. Or if we spawned some loot there, the player would never be able to get to it and stuff. So one of the things I want to look at today is maybe culling these little inaccessible regions out of the map. And then I think we'll also maybe have a look at diffusion limited aggregation as well, if we have time. So, and I would also like to make some tweaks to our room generation. So our room generation at the moment, we have, if I scroll down, so when we do room-based generation, we have a couple of ways of doing it. We can randomly place rooms, which is hit and miss as to whether or not it gives us a nice layout or not. And we've also got binary space partitioning, which gives us some more interesting spaces. What I'm kind of thinking though is I would like to be able to chain these functions the same as we do the generator functions. Or to at least apply sort of changes after the fact to them. That way we could have our binary space partitioning as a base, and then we could sort of apply. So what this is doing is it's slicing sort of the image into various it's slicing the image into various slices. So it will dissect the image in half, and then it will pick one of the halves and it will dissect that in half, and then it'll pick one of those and cut that in half, and it keeps going, slicing in half either vertically or horizontally. When I say half, I mean into two, and it'll pick a random spot between each of the edges and cut it there. And then what we're doing at the moment is, because that gives us a very structured layout, we're then creating rooms inside that. But I think it'd be interesting to be able to potentially do both. It could be that we just generate a separate BSP method for that. We could add a resize parameter here, actually. Yeah, I think maybe that's not bad choice. So then if resize that else actually, so that that's actually this is probably a quicker solution. So then we can have a no resize version. Yeah, this creates more of a interior sort of layout, I think. So we probably want to go for smaller rooms, something like this. Sorry. More rooms. Maybe we tweak the sizes a bit more. Still favoring some pretty large ones. Maybe we just need to go ham on the number of rooms. Oh, sorry, where are we? Yeah. Number of rooms, we can go for, so if we go for 50, alright, that's not terrible. If we go super huge on that, yeah, we get some quite condensed little spaces. So, and I think with some better room connections, we could get quite a nice little interior map on here. Let's actually go. This is giving us quite a snaking structure, whereas I feel like we should probably want a bunch more dead ends and things in this. I feel like a better, though we do have some. Oh, yeah, and this one actually has a loop to it. I like this. This isn't too bad. So yeah, this will be more for like internal shapes. We do have some space here where it's overlap. It's creating varying sized borders. So I think that's what we've actually found is a bug in our partitioning code. So when we split, no, this should. it should actually be fitting. So why do we have slightly larger walls, say, here than we do here? So we split it at a random point. Yeah, here we go. So we pick a random point between the width and the min height minus the spacing. And we guarantee that the room is big enough to fit the spacing. Oh wait, what did I set the spacing to when I generated this? Spacing is 1, okay. So we create the initial one. By adding the spacing on all sides. Pick the split. And we add the x and y to that, and then we go split plus 1. Sorry, x plus the split plus the spacing. We do the width minus the split minus spacing. I don't see anything obviously wrong with the maths there. We can come back to it later. Okay, what we're going to look at today, we're going to look at the flood fill. So this will be a generator similar to our cellular automata. So let's go start. We can put it just after that. Let's start with the this setup as well. So cellular automata, where are you? Here we go. So yeah, what we'll do is we'll add in a and we will go for so we're going to use a flood fill. And a flood fill expands from a point outwards, all tiles that are a continuous region. So we will have no, that was not the generator we were after. This is the one we were after. So what we're going to try and do is use the cellular automata that we had before. third time's the charm. Third time's the charm. Okay, so let's fill these are okay. Level 3 headers. Nope. So take out the frame. Yeah, so we want to keep those the same, and then we'll have a final step. This is not actually going to take. I mean, it's a bit wasteful to have a factory for something that doesn't actually take any a factory doesn't actually take any parameters, but we'll do that anyway for the sake of it. That is not what we're after. So we want to return the generator. And then we'll pass it. If we run this now, oh, typo. Okay, so we're still getting unconnected regions. So what we're going to want to do is loop over our map and make sure that every pixel is specified to be within a region. If we find one that isn't, then we flood from there, and it's spanned out, and we'll mark every pixel that is, every tile that is in that region as being part of it. So to do that, first actually we'll take a value because we never know when these will come in handy in other contexts, as we've seen some of our previous generators. Excuse me. We also have a flood method. Yeah, we'll take context X and Y. Go away, Copilot. So we're going to want to keep track of these regions. This will be a list of actually that'll pick up its type fine anyway, but then we going to want regions, which will be a list of sets a list of tuples where one is the region no here we go, yeah, we'll go for a dictionary, and then the property for each will be a set of coordinates. Oh. We'll set that as an empty dictionary. Yes, then we want to loop it over the size of the map, and if region map y x is not equal to -1, then we're just going to continue. Actually, we'll go for that, and or context data x and y is not equal to value. Okay, so we're only going to look at we're only going to run our fill if the region in the map is not -1. Though, do initialize to 0? Let's initialize to 0. Yeah. So if in our little lookup table of regions for each tile, if that is not equal to 0, that means we've already assigned it to a region. Hey Aaron, welcome in. Welcome in. And then also we're going to look and see if the cell itself is the one we're looking at, so in this case the air. And if it is, then we will flood with that region. So we're going to want our region map as well. So here we're going to want context, and we want our region map, which is a list of lists of integers. Too many brackets. How about x, our y, and our region? So, okay, so first thing we're going to do is we're going to have to look around the cell, the item we're in. So we're going to go if, well, so we're going to map the region that we've selected, and then we're going to go for no. So then we're going to go for Actually, let's do this. So we're gonna go. We're gonna set the stack. While there's a stack, we're gonna go. We're gonna take X and Y off of that stack. And then if the context.map yeah, that's the same logic as this one. So that is not equal to 0, or we are at or it is a wall. Then we stop. We set it to the region, and then we will go if the x is greater than 0 and iy is greater than 0 and yeah, if iy if ix is greater than 0 and region map y ix minus 1 no, we want context, sorry, we want context map and context dot data y iy, sorry, ix minus 1 is equal to our value, then we add it to the stack, and then we want to do the same for the other edges, and so this should give us a this should give us a this should find the region, but we also want to record the location. So I think what we want to do is regions equals set, and then we'll increment the region afterwards. So each region, call that the region ID. So what we're doing here is we're looking in each direction, and we'll just keep looping, and we'll keep adding each value in until we hit a wall. So this is no, this is check left, check right, check up, and check down. We should probably return our set of tuples here. So what we'll do is, as we add things, we'll also then go, we'll add the iy and ix. we'll add the coordinates of our value into there, into our results, and then we'll return the results at the end. So then this here becomes, we set that like that. So that, okay, so now for each, X and Y, if the cell that we're looking at, the tile we're looking at is currently still at an uninitialized region. Actually, I think I am going to, yeah, sorry, if it's currently at an uninitialized region, we will, and the value is in the data set is the kind of tile we're looking at. So in this case, we are looking at air. Then we are going to do a flood on that region, and we're going to increment the region ID. So first time we pass through, we'll get region 1, then 2, then 3, then 4, then 5. And yeah, if it's not if it's not uninitialized, and if it's not the value that we're looking at, we're just going to skip to the next X and Y combo. Okay, so after that, we're going to have a list of a dictionary of sets. Let me quickly find a good specifying colors. So we want to set yes, we want to look for color maps. Where are the predefined ones? So I think there is a bunch of existing color maps that we can use. List of named color maps. Here we go. No, that's named colors. There was, here we go. So we want something that has a HSV. Let's let's go back here. So then we can go color map is equal to HSV. So now if we run this, we should get, okay, no, that's not, that is not what we're after. That was, mistakes were made. Okay, let's give this another go. So I think we're outputting far too much data, and that broke our notebook for a sec. Okay, so so this should be applying. I'm sure there was a grayscale in here. It's just grey. Okay, so this should be giving each region a different color. It's actually scaling it. So we're definitely adding these in. Let me check left or right. Let's simplify this down for now. So we'll go flood. We'll do one region. And we'll start at the center of the map. Okay, so that didn't find us anything. Mostly because that was a wall. So I think actually if we instead of this we go for y and for x, if context dot data y and x is not equal to value, continue, and then we'll break immediately after, and in there we'll do our flood fill. So we're just trying to find the first air tile in the map now. And once we find that, we will flood it. And we'll see what we get as a result. Okay, interesting. So this has moved in a really weird pattern instead. So let's just try running one of the so that ran more times than it should have. Wait, why has that run so many times? Ah, hang on, so let's break. Sorry, break 2. Oh, I'm actually getting my languages modeled now. That is definitely not a Python feature. Right, and then if yeah, if the length of the regions is greater than we can break, that will mean that we only run it for one. So running for that top corner though. So we're getting the top corner, but not the rest of it. Oh, okay, so this has somehow smoothed the edge there. Okay, so let's see what happens on if we give it 2. So it's found here. But it hasn't filled in the region. So it's just gone down. Okay, so we can see the stack that is created here. So it's added in a bunch of different. Oh wait, we said to break after the first field, didn't we? So let's try this again. So it's not filling it. So we can see the stacks here, the stack here. So we start off with we start with an empty one. Yes, because that's our corner. Okay, so then we get the next one. So that is there, and then the next one will be this one, which will map to this here. But then we're not expanding out from there. This is, so we're finding it and we're filling, but we're not actually expanding properly. So we append the things we need to the stack. This is let's hi Kongville, welcome in. We are currently scratching our heads as things are not working as they should do. Let's take the condition out and see how that works. So we're trying to find the regions in this generated image. Yeah. So we're trying to find the regions within this generated image. So we're starting in this top corner and we're scanning down column by column, looking for airspaces, i.e. this bit, and then from there we're trying to flood this whole area with a region till we've filled it up completely. And then once we've done that, we keep moving on, and we find every other discrete region within the map, and that should allow us to come back and fill in all of the smaller ones. But instead, when we try and look at where we've found, we're getting this, which is not what we're after. Let's go back to, so we're going to try and check everything. There we go. So we're going to if we have found more than 3 regions, break, and then we'll do the same in the lower loop. So we're just trying to exit out of our loop early here. So we should find three regions. So it's found, which it has not done. Let's get a bit more information out of what's happening. So it doesn't look like it's looping properly. So while there's items in the stack, it should be looping around and adding more items. Okay, let's so we have our region map and it's set to 0, so we must be hitting this. One tiny mistake, and that's had us scratching our heads for what? 10 minutes now? So I had X and Y in here instead of the items X and Y, so it was just looking at the same coordinates each time. So now when we run it, the more you watch this, the more you're impressed by those who know how to code and impressed by the amazing programs and games there are. Yeah, I mean, programming is just a skill though, and the more you do of it, the more you learn, and then even when you've been doing it for decades, you still end up screwing up all the time. So it's a weird skill where basically you get better at it by doing bad at it, because nobody learns from success. So the only way to actually be senior at like a senior in your industry is to basically make more mistakes than everyone else. And obviously to remember those mistakes and make sure that you don't make them again. But okay, if we unrestrict this now, we're still only getting one region placed. Oh, it's exactly the same error again. I fixed it in one place but not the other. Okay, there we go. So this found this whole big region here, but it only found one. I think that might be because of our color. So if we go HSV, so we're only finding the first region, and the rest is not getting assigned. Have I done something stupid? Again, quite likely. So we put our X and Y onto the stack, and then while there is anything on the stack, we take an item off of the stack. If that item is not no region, and the so if that region is not unspecified, sorry, yeah, if that x and y is not an unspecified region, and that x and y on the map is not an air, or if that region is not an air block, then we don't do anything else. Otherwise, we set that x and y to the region ID. We add that x and y to the results. And then we add the neighboring cells. We add the left, the right, the up and the down coordinates into the stack, and then we start over at the start, where we grab the next one off the stack and we continue. So that should be filling the whole area. So it did work for a while. I think it's finding this section here, this one, and it's sort of giving up for some reason. Let's print it instead. Okay, so it's assigning different regions. Maybe I am rendering it badly. Okay, so yeah, again, we found one region, but we've not found the others. Oh, hang on, it's because it's because of the values, isn't it? I think this is just to do with how I'm assigning the values. Okay, no, I think I see what's going on. So the problem is we're assigning values 0 through n. Damn it. No, this is not what I want to do. Where is our code gone? Here it is. Yeah, so we're assigning values 0 through n, and they need to be 0 to 1. This is just me abusing math packages that I don't understand fully to print out the data. So math to region map is that's cool. That's a lie. That is closed. Oops, sorry, I'm missing the equals. That's why it's confused. Okay. Yeah, so we're going to go through each and we're going to time... we're going to divide everything by the last region ID. That's still not giving us different regions. Okay, let's do some really stupid instead. So this will be for call in, sorry, for V in column, for column in column in region map. So we're going to loop over each key and we're going to generate a map for each one. So this one we've got the corner there, region 3 is everything, and then region 3 is actually everything. No. And it's not managed to find all of the extra smaller regions. Oh no, I told it to stop after 3, didn't I? That was prime idiocy we had going there. Okay, so now we've got that, okay, so it's finding all of the different regions within the map now. So we've got all of these numbered regions. Okay, so now we've identified the regions, and I've stopped being an idiot for now. I'm sure it will come back. With that in mind, if we go back to just rendering out the regions. If we render out these regions, are we going to get a nice, here we go. And then if we change the color map to something that has a selection of colors, or rainbow, here we go, we should get some more variation here. Yeah, we can see all of the different regions now outlined on the map. Is there a better... yeah, we can see it's all broken down. So we've managed to find each of the in each independent region now, and give it a color. So with that in mind, we should now be able to now we need to find the largest set. So we need to find the largest region. So we've stored each of our regions in there. When's it? All right. Sorry. Where are we? So the largest region. So so if we take the items in that and then we sort them by the size, yeah, we're going to sort that list by the length of the key, largest first, and then we're going to go regions, for XY, for each region in the region list, for XY, then we will fill in the area that we don't care about. Which actually makes me think this should be we should be passing in the wall rather than value, so that should be if it is equal to. So given that, okay, so we're just taking the largest region and keeping that. And then if we, here we go. So yeah, this is all one big continuous region, and any extra space has been culled out of it. Let's zoom out a little bit so we can get the whole thing on screen. Okay, so these are, all right, this is, oh, that's a cool one. So we're generating some interesting shapes now. Let's zoom back to, let's reset the zoom. Okay. So yeah, so we've got the, we've managed to strip out all of the extra space now. And we're only getting the region that we're only getting the largest continuous region on the map. Oh, sorry, my door had popped open. So okay, so this gives us a slightly nicer version of what we had before. But yeah, the only trouble with cellular automata though is sometimes sometimes you get a really good result, and other times it's just a tiny bit inside. What happens if we remove the symmetry as well? All right. Oh, okay. So these are pretty interesting shapes that we're getting just from here. So this is cellular automata plus flood field color. I think the automata and the flood field are two main factors of this. But okay, this is generating some quite cool cave-like shapes. So these would all be pretty good for a more open map, I think. I mean, this one's missed a large chunk of the map, but it's still not too bad. Same here, we've got a large region that is sort of uncovered. But there's no reason why the whole of the map has to be sort of square, is it? This gives us more of a less square sort of approach as well, I think. So when those are, if you can imagine, once we've got this working and this is all filled out, then like we'll also do some other stuff to subdivide this. So some will be grass and then into some swamp or something. Or we'll have stone and then into some sort of, we'll have like cave and into like a damp cave and out. Maybe put some little points of interest in the spaces that they'll fit. This is not bad though. Okay, cool. Let's so that is our so we've now ticked something else off our list. So if we come back up to our list of things we want to look at, we have unreachable area culling. So we've got that in there now. If we run all these again, we can go down and we can update some of our fancier outputs at the bottom. So I feel like this should actually add, we want to add the generate flood fill culling in there as well. So I find the outputs of this one in particular, like, I don't know, it's like this is in my head, this is like going to be a more useful generator, in that like any kind of, all of these so far would make like an excellent sort of boss arena, like a big cave for a boss arena, right? So this is by far the more useful of the generators, but this one I just find really mesmerizing. Like the results from even from the previous one were, and then this one I think it is equally so. equally so as well. It's just the outputs are just like the abstractness of it is and I guess the symmetry as well. I think the abstractness, but also the symmetry of it together. Just yeah. I think I could just I could watch the outputs of this for a while. But, right, we have to leave it alone. Leave it alone, because we are going to have a look at what did I say we were going to look at next? Oh, in the stream. Diffusion limited aggregation. So DSL. So this is similar to our random walk, our drunkard's walk. It's another form of random walk algorithm. And this one's already producing some quite interesting results, but this is another variation of that. So we have diffusion limited aggregation. Uses random walkers to choose cells adjacent to a set of seed cells. The walkers move around similar to a drunkard's walk, and then when they step into the and then when they step into the carved area, the cell they stepped from is added. Okay, so what this means is similar to our drunkard's walk. In our drunkard's walk, we basically spawn our drunks in the middle, and they sort of wander off, stagger around, and sort of carve out as they go. But with the diffusion limited aggregation, we sort of carve out a set in the middle, and we just spawn drunkards around the thing, and they just wander around. And as soon as they step into the area that is being carved, that has already been carved out, then we mark that area. We mark the previous place they were stood as part of the carved area. So instead of them carving out as they go, they sort of wander around the outside and fall into the area, and then the place that they fell from gets added. So it should give us something similar, but not quite, but different. So we're going to generate DLA. We probably actually steal much of the signature of our drunkard one. Oh, what are you streaming today, Congo? Is it Valheim? Okay, so we've got. Oh. So this is generate DSL. And we'll take a copy of that as well, and this is this is diffusion limited aggregation. Planet crafter. Cool. Well, good luck with the planet crafting. So we'll take the, we'll get the total size of the thing. We'll take the total size, the total and the count. Oh, and thank you for the best wishes. So we're gonna take our count, and then we will. We need to create a seed though. So we have our. We have the field. Let's add another quick simple generator in. We can just add a rect generator, because we will probably need that for our a simple generator that so we're going to create a very basic one. Oh. So this is going to be generate rect, and we're going to go for XY width actually we'll go for width height XY and this is going to be set to air. These will be optional. These will be optional. So we're going to basically require a width and a height, and then an optional x and y, and then we're going to generate some stuff. So we'll do x is equal to x or context dot width divided by 2, and y is equal to the same for that. Then we'll offset by the width, and then for ix in range x to width. For x is for ix is equal to x to x plus the width, and then for if the as long as ix and iy are within the image, if they're not, we'll continue, and if they are, then we'll set it to the value. Okay, so that's a very simple. This gives a very simple one where we can go width is 20, height is 10, and then if we run this, we should get, oh, we get an error. Okay, we'll not override those, and we'll use a different variable. There, yeah. So we can draw a simple rectangle somewhere in the map. And we can determine where that is drawn as well. So we can go 150. Yeah, so we can draw it. We can draw a shape somewhere on here, and this is how we're gonna use that here, because we're gonna need a seed. So we're gonna go generate. We're gonna chain these. We're going to generate a rectangle, and we're going to say I don't like the fact that these are named inconsistently with everything else. So make sure these width and height. Okay, so we're going to go minus half the width, minus the height. That is like so. this is width and height. Okay, yeah, so for this we can go, we draw a if we draw about 5 pixels in the middle, oh no, that's generate. Draw 5 pixels in the middle, then we can start to apply our random walkers. So we'll spawn a walker, and then we'll have to wander around until they hit one of these cells, and then they will draw their then they'll draw their sort of spot. So set walkers to 0. Well, the count divided by the total is less than the ratio. So x and y is equal to context dot random point. So we'll pick a random point in within our image. If the value is if the value is equal to the brush value, then we continue. So we kind of want to do very similar to the drunkard's walk here. So we're going to pick a random position. We're going to choose a new x and y. Okay, let's copy over the drunkard's walk, because this is going to be very similar. And then we'll edit the drunkard's walk into this. So first up, the bit that we're going to take out drawing the current cell. So this is going to wander around. We had some defaults that we set. Yeah, that's not going to work in this case. So we are going to set x and y to a random point. And steps to max steps. And then we'll do the same here. So we want to do the same. So every time the walker runs out of steam, we will recycle it with a new one who will spawn randomly within our level, and we'll set the max steps and walker to as such. Okay, and then we're going to want to keep our original so we keep the original x and y. And when we've made our step, if the I think if we wander out, actually if we wander out of the map on this one, we probably should just cull it and go. We can have a look at that afterwards, but if the context is equal to the brush.value, so if the cell that we're stepping into is equal to the brush.value, then we increment by the count, but we use the original x and y as where we draw, and then we decrease, and then we spin up a new walker. So then I guess we can go steps is equal to 0. Yeah, and that will force a new walker to be spawned. So okay, so we're gonna pick a random x and y, and we're gonna give it a maximum number for our walker, and we're gonna in that maximum number of steps. And then while we haven't filled in as much of the map as we want, we'll stash the x and y that we're in. We'll update x and y to be one cell over in a random direction. If that cell that we've walked into is our brush color, sorry, our brush value. So if that, by default, that'll be if that is an air block, then we will draw we'll draw it at the positions that we stepped out of the brush, and then we will spawn a new walker, else we will carry on going and run our steps down. So if we now run this, alright, so it's creating, it's a very slow algorithm. So I suspect what we actually need is a lot more walkers, but considerably less steps each. Hi Splash, welcome in. And I've been logged out of my own chat again. This is helpful. One of these days, OBS, you will sort of figure out that logging me in before the stream is maybe a good idea. Because now I've got to do all kinds of password shenanigans while I'm streaming. And if I wasn't streaming specific windows, it could be that could not be helpful. Okay, so let's get ourselves logged in. How am I doing today? We're doing good. We're doing good. We have already looked at creating cleaning up some of the maps. So we have our cellular. If I can actually find the original, yeah, we have our cellular automata map generation, but stuff like this, it creates lots of little regions that we can't access. So we extended that today with a new generator that clears out any unreachable regions and just keeps the largest continuous region. So we've got a nice continuous sort of space now being generated each time we run this one. And everywhere is accessible from everywhere else. It's creating some quite nice cave-like sort of structures. I think this is a really good. I think this is quite a nice little algorithm we're at now for like big cavern-y sort of generation. We have a new composite one based on that though, that is this one. That is quite mesmerizing in the shapes it's producing. So once we mix those two with some symmetry, we're back to generating art again rather than maps, but yeah, we're getting some really interesting patterns out of it. Oh, look at that one. Yeah, and then now we've moved on to onto a new algorithm, which is the diffusion limited aggregation, which works similar to our drunkard's walk that we were using before, but instead just adds on to an existing area. And I think this is actually creating some quite cool little sort of windy shapes. If we have where's the drunkard's walk? So we were applying cellular automata to the drunkard's walk, but I think once we smooth this out with cellular automata, we're going to get some interesting sort of shapes. The only trouble is, I think this is it's a bit. So what we're doing this time is we're sort of spawning a drunkard somewhere on. We're marking out a little square in the center, and then we're spawning a random drunkard somewhere in the map, and letting them stagger around until they stagger into the area that we've already carved out. And once they stagger in, we sort of break the wall that they staggered through last, but we leave everything else. We leave their trail out. So it just sort of adds, each drunkard adds one little bit more to the space. Yeah, I think we need more drunkards walking shorter distances, I think, is the. So that's a bit longer. Oh. So we're getting some interesting patterns. If we take the lifespan of them down, yeah, this is not bad. We're getting some very nice edges to it. I think if we take one of our room-based generators and run it through this, we'll get something really interesting. Let's have a play and get this into a good shape first, and then we can start to combine it with some of the others, because I think we're going to get some really interesting results out of this. I think it's going to have a similar effect to how the cellular automatus improves the drunkard's walk. I think this will potentially, if we run any of our more boxy generators through this, and then through the cellular automata, we're going to get some quite interesting shapes out the back of that. So let's yeah, I said earlier, I think instead of what we're doing here, we will we'll do if x is is greater than 0 and x is less than the width. Okay, so while we're inside the map, we'll go with that. Else we'll spawn a new drunkard. So that should hopefully mean that if they run into the edge of the map, then we'll just call them straight away, because we kind of want them to head into the middle. So the edge, if they're out running into the edge, it's probably they're going to be less likely to get back to where we want them to be. Okay, so that made that. That's come out. That feels like it's going a bit quicker now. What else can we do with this? I think I can also potentially make this a bit quicker. Okay. So we've got X, Y, and our steps. Okay, I think I'm going to check the steps at the beginning. If steps is less than or equal to 0, then we set X and Y, and we set max steps. We increase the walkers, and if the walkers is greater than max walkers, then we start over. Okay, so that gets that out of here. That also means we can do some shortcutting. Yeah, so if X is outside of the world, then steps equals 0 and continue. So this is just going to start again, which means we don't need to wrap this bit, and this can become a bit simpler. Then let me move this up above. I know we want to kind of take we want to take our step first though. No, okay, yeah. Okay, yeah, it's still a bit simpler. So we cache out X and Y. We decide whether or not we need to spawn a new drunkard. So where our drunkard's going to pass out and we need to spawn a new one, we'll do that here. Then we'll take a step in a random direction. Then if we step out of the world, then we will basically reset the steps to 0. So we spawn a new. So we'll pass out our current drunkard and we'll spawn a new one. And then if the cell that we step into is the brush one, then we will draw our previous location and reset it. I feel like we can probably make this a bit quicker by no, we want and here's a okay, so we go if we go and look at our context, we have a get neighbors. Okay, we have a neighbors for. So what we're going to add to here is a cardinal neighbors for. We're going to only check the X and the Y. So so if dx if dx is not equal to 0 and dy is not equal to 0, then we'll continue. Actually, no, this is much the same now. Okay. So I was thinking we'd need something quite different, but we can actually add a cardinal as a boolean. So that's false. Yeah, and then here we'll go if cardinal and if it's cardinal and not dx. Yeah. Okay, so one of these has to be 0. So if it's cardinal and one of these is not equal to 0, then we continue. So that'll give us our neighbours within just the either side or up above and below, and we'll ignore the four corners. So if we come back to our diffusion aggregation here, then we can go go we go neighbors for x, y, brush dot value cardinal is true is greater than 0. So basically, if any of the neighbors of the cell we're in are already set, then we will run this anyway. That means we don't have to collide, we just have to pass by. Oh, I did not run that cell above, so let's run all the previous cells. Give this a run. Okay, that's different. Oh. Okay, so we consider the walls. When we wrote this, we considered the walls to match. Okay, let's take this out. This is not working for us. We have to find another way. But I suspect what we had here is roughly what we will need. So we'll go back down to our diffuse, our diffusion limited aggregation, and we will go neighbors are equal to the selves will be context. So our new x is in each direction. Okay, so we're going to go if the context is, yeah, let's flip this. If the context is greater than 0, and the x is greater than 0 and the and less than that, and okay, so we're going to flip our statements around here a bit. So we're going to check that it's within the bounding box of the world and that it matches our brush value. And then here we're going to go if not, if not, the dx is equal to 0 or, so we only want to check the cardinal directions. There we go. So now we're counting the neighbors in each of the directions, and ignoring the edges. So then we want to go, if the neighbors is greater than 0, then we exit. That's still not correct. So we look in each direction. We require at least one of the offsets to be 0, so we're only looking up and down or left and right, not in the corners. We take we look at the x and y, and then we look at the hang on. Oh, I messed this one up. This needs to take the context x and y and width and height into account. I'll come back and look at that after. Yeah, so we're looking at each of these, counting the neighbors up. If the neighbors is greater than 0, then we carve it out. So what is going on there? Let's start. Let's take this slowly. So we're going to have 0 if oh, hang on, that's part of it is that we're doing it in the wrong place. So before we move, we want to go if so we don't actually need to stash the original x and y anymore, because we're going to examine things before we move. So we want if I think we need to update a couple of our bits. Actually, we need to update the last one as well, in that we're not looking at the right bits of data, but we can quickly fix that up. So neighbors is equal to 0. so we'll draw if that is equal. If that's equal to value, then neighbors is incremented by 1, and then if the neighbor is greater than 0, then we draw. Oh, we missed a colon. Okay, so we're going to try. Oh, it's brushed up value, isn't it? Okay. Still not. That is set. We're going to set these there, then we update. We draw OX and OY. These are the wrong way around, that's why. This is probably not helping. So we're going to move this below the stepping part. Oh, I know I've spelled this wrong. Okay, this gets back to where we were, hopefully. Out of bounds. Because we don't have the bounds checking, that is here. Okay, it's still not. Sorry, and then O and OY. I think our actual bounding check's a bit broken. We should probably actually do that properly quickly here. Okay, so what we want to return is if x is greater than equal to self.x, and x is less than self.x plus self.width, and y is greater than equal to self.y, and y is less than self.y plus self.height. Okay, so that's what we're actually checking. If oh, that should be contains. Generator. Where is our here we go. So we're getting values outside of the range. Why? Let's just drop that in for now. Okay, this is suddenly not working as well as it was. Let's go back to what we had and we'll stop messing with it. Okay, no, we've really messed this up now. What have I done? So we draw our x, no y. This isn't okay. Some of this stuff is definitely okay. I need to come back and look at some of this stuff because it's definitely not correct. But it shouldn't be breaking in our current case. So given that, why is this suddenly not functioning as it did. Oh, what have I done? Zero, isn't it? Yeah. Okay, so let's. So this was working. What have we done to break it? So we set the walker to a random spot. If the steps are less than 0, then we reinitialize our walker. Then we pick a random direction, move in it. If X and Y are outside of the world, then we set steps to 0 and start over. And if the value of X and Y is what we're after, then we draw at the previous position. That should not be generating this, even though it is kind of cool. Maybe we're continuing with some random. Okay, we did have this working and now it's gone completely to pot. What were we doing before? We had this below. So if So if we're outside the world or we run our steps, we spawn a new guy and we continue. Else, if it matches, then we draw the value and we I think this is what we had before, more or less. Okay. That's working a bit better, but it's gone back to being very slow again. So, like, okay, can we speed this up without breaking it this time? Okay, I feel like this is moving that there should work. Then we just need to set steps equal to 0. It's the trouble is it's going quite slow, so it's not taking very long to run, but we're running it on like a 200 by 200 tile map at the moment, and this is going to be one of many steps. So ideally we want it to run fast enough that we can run it on like a much larger map, so 500 or 1,000 tiles across, and then we're going to have a bunch of other passes on top of that. So, and we want that to run in a reasonable amount of time. We don't want to have people sitting there waiting for the game to initialize, sort of thing. So, okay, so it should be that if we should just be able to set steps to 0 here. Then we can okay, so if that's not in the world, then okay, if we run it now. So why has it suddenly gone so squiff? Is that still broken? Let's move. Okay. Okay, so this one is working. We move that above. It still continues to work. We move this to here. Still works. Still works, okay. So if we set this to that also still works. Take that out. I feel like this is much like what we had before. So why is it now working? Okay. Okay, so let's try this with looking at the neighbors. So we're going to want Ox minus 1 Okay, so let's try counting the neighbors up, and then if we want to go, if count neighbors is greater than 0, then we are going to, okay, so we're still getting the same result there. I think we can then move that step above here. Use X and Y instead. Well, it actually won't make a difference at the moment, but okay, so we get, okay, so this is some progress. So we can now take these, we don't need to keep the original X and the original Y because we are looking at it before we change it. So this is going to give us our, so this is going to count the neighbors. So we're basically looking at each of the, at each sort of side. We're looking at each side and we're going, is it inside the world and is it set to the value that we, to the X and Y value? And if so, then the neighbors, if any of those are actually any is probably a better, y plus dy for then this will be y plus dy and x plus dx. So we can take a generic case for this, for dx dy in, and then we'll store all of those offsets instead. Yeah, so this will loop over each of so this will check each, this will check for each value in that loop instead. And in theory it should stop after any of the match. So it should be a little bit quicker. List index out of bounds. stray minus there. Okay. I appear to have made it slower. Okay. Well, we can revisit and try and speed this up later, I think. But I think let's have a quick look at what we get when we try and combine this in with some of the other algorithms. So if we go generate a rectangle, and we'll go width equals 5, height equals 5. So that'll put a small seed rectangle in the middle, and then we'll go generate DSL. Why did that not? I want to get the DSL and the cellular automata working together. Ah, hang on. That's why, because that's so weird. Let's go for 0.25. And we'll also put symmetry to both. That's all. Okay, so this is I think so this may be doing a better job of than the Drunkard's Walk actually for a sort of cavernous look. But the other one I wanted to try was if we take something like our room-based one using the Drunkard's no, and then we just generate that normally. Okay, so we get what do we use for this one? Okay, so we'll borrow these parameters from above. So it's giving a nice spacing. Yeah, so we get this shaped room, and then if we then take the DSL and run it through here, Oh. Oh, sorry, I've wrong key. I really need to bind the zoom reset to something that isn't a numpad key, considering I don't have a numpad. Okay, so then if we chain the room generation and then pass that into our DSL generator, this should give us this should then pad out the rooms. Ooh. Oh, hang on, no, this isn't right. Oh no, I did this completely wrong. It should be bolted on afterwards, sorry. And the room generation will not work like that. Okay, let's put a lot more spacing in. I think we're probably hitting the... Okay. Then we want our fill culling added on after that. Oh, I like this. This is giving... So each of these is guaranteed to be big enough for a square to fit inside, but... Okay, out of interest, what would happen if we then... add a user... Okay, so for a square, we're getting at least the base square, and then we're getting sort of extra details added onto it. It's creating some nice... Oh, look at that bit. That's some interesting terrain there. But yeah, it's creating some nice extra parts. But then if we instead start with the Drunkard's Walk... Okay, maybe that's a bit too high still. Down to 25. 0.3. It's starting to get something a bit more. 5 to 0.4. Oh. Okay, some of these are... These are actually some pretty nice... this is some nice sort of cavey, room-based cave terrain that we've got going on here. We're actually getting some really nice results out of this. I was not expecting that, to be honest. Yeah, these are quite nice looking cave levels, right? The walls on these look really sort of organically shaped. and we're getting all these little sort of bits coming off of them. Yeah, this is good. All right, yeah, I think. So what is this? This is BSP plus Drunkard's Walk plus DSL plus cellular automata. Okay, so that's giving us that. This is DSL plus cellular automata. Oh no, and this is flood fill as well. So it's like, so it feels like every time we add a tool to our arsenal, this is actually getting better, because I was thinking that this would be a better, potentially would be a nicer Drunkard's Walk generator for the rooms. Probably shouldn't have the symmetry on that one. Yeah, I was thinking this would be a better Drunkard's Walk, maybe for some of the room generation. But instead, what we've gotten is something that can also take a existing layout and give it more of a rugged edge. I think when we swap out the Drunkard's Walk for the DSL as well, we get quite a nice shape. But I think for now we'll go with the Drunkard's Walk as the base. But yeah, so we start. I think this has actually come out a lot better now. I was not expecting the DSL to actually be such a good second pass function. I was thinking it'd be a good. I was thinking it would be a good first pass sort of carver to carve out the rooms themselves, and I was thinking after that we'd run it through cellular automata and get the smoother edges. But I wasn't expecting it to actually be a good second pass in and of itself. Like just carving out more on top of the rooms. So even if we take so even if we take a standard boxy layout, if we crank this enough, yeah, if we crank this enough, we get, not only do we get a square rooms, which means feature placement is probably going to be easier. We also get our cave edges. I think so far, I think out of all of them, I think the Drunkard's Walk as the individual room carver, and then the DSL as a second pass, it's giving some really nice results. Yeah, we just need to make sure that the ratio is not so high that we lose the overall sort of shape of the dungeon and the corridors. But that's yeah, this one's not a bad one, and oh, neither is this one. Okay, yeah, so we're getting. I think this is I think that's actually some pretty good. I think that's actually a pretty good combo there. I think tweaked the numbers well enough. I will probably make a few changes off stream so that I can put. Oh, that's a nice level. Yeah, I'll make some changes off stream because I think some of our utility classes could do with a little bit of love. And I'll tidy up I might tidy up, just go through and tidy up the generators we already have, see if I can make any of them a bit faster and so on as I go. But we're getting some pretty nice generation here, so I think this is a good place to call it for today. Yeah, this is, and I think we've made some really good progress. I think this is come out far better than I had ever dreamed it we were gonna get by the end of this stream. So yeah, it's like can you imagine this once it's actually. So this is just at the moment what we're working on is is carving out the outline of the level. And then after that, we're going to do some passes to sort of put some points of interest and some enemy spawns and so on, and some different, to basically mark off regions where we can sort of maybe mix up the tile set. So maybe we'll have damp cave, dry cave, dark cave, sort of thing, and then we'll generate inside. Place some monsters in there, carve off territory for different species of monster or mobs, spawn some of those in. We can maybe, we'll try and find something that finds the two furthest points. So we'll maybe spawn the entrance over here and the exit over here, sort of thing. And then that's it, off you go on your little, on a run. It's I think we're gonna get some really nice results out of some of these generators. So yeah, so we have something like this for sort of more organic cave levels, and we have something like this for boss, for a boss arena. Maybe, yeah, and then we go something like this for sort of more of a interior inside a castle style tile set. Give each of the rooms a different sort of theme. Something like this for more of a dungeon style tile set, like gloomy stone walls and things, moving around through that. It's and I think this is what I want to kind of do with the game, is that each time you descend a level, we'll sort of pick a generator and a theme, and we'll send you in. Can I do hidden doors? Yeah, this is something I've been thinking about. Is it would be really nice for each room to have a secret area. I'm not entirely sure how I can do that with the procedural generation at the moment. It could be that I have to sort of pick a spot and then force it in somehow. Maybe it would pick part of this. Maybe it could pick here, and then it would sort of try and fill in around it so that or something, but yeah, it's but having like a secret room, because I was thinking having a secret treasure room or just multiple secret treasure rooms per floor would be kind of cool. But yeah, but no, okay. Before we get distracted into more things, I think I'm going to call the stream for today. It would make people explore the maps more thoroughly, I think. Yeah, so I think the other thing I can do is I can look for. So there are algorithms we can run to find like the most distant two spots. So potentially that could be, even though they're not far as a crow flies by the route you'd have to take, it's probably these two. But then we've got this area over here that there's no real motivation for you to go into. So I can sort of find the areas that are off the beaten path and then spawn treasure chests and things into those. So that's one thing we will look at. Even if we don't manage to get secret rooms to encourage exploring, we'll at least have I want to go with sort of a no dead end goes unrewarded mentality to it. So if you have gone off down on some tangent and all the way down and you've got to a dead end, then you at least get something for it, and then you can backtrack and find the actual way. Yeah, so with that, I think I'm going to call the stream for today. If you've enjoyed the video and want to see more, then give the video a thumbs up, give the channel a subscribe, and I will be back next week with some more, and we'll try and knock a couple more of these algorithms off. So we can take this one out for now. But yeah, some of the maze algorithms and the Delaney triangulation is going to improve it's going to probably give us equal levels of improvement as what we've had today. So I'm quite looking forward to some of that. But yeah, but I will see you all next week. Bye.